Hey everyone, Mr. Hauk here. In today's video, we're going to look at some more examples of how to solve triangles using the law of cosines. So in the previous lesson, we derived the law of cosines. We found these three statements right here that make up the law of cosines. And we also saw the two scenarios where we're allowed to use the law of cosines. And those two scenarios are when we have a triangle given the three sides, or we have a triangle given two sides and an included angle. What we want to do today is just look at some more example problems. I'm also going to show you how we can make the calculations a little more efficient, how we can plug them into a calculator and get to our answers a little more quickly. So today is really just going to be a video about practice, okay? So here in our first example, and for each of these examples, we're going to be solving entire triangles using just the law of cosines. So here in our first problem, notice that we have a side angle side triangle. We have two sides and the angle that's in the middle of them, which is the included angle. So what I'm going to do first is I'm actually going to go ahead and solve for side C. Me personally, when I have a triangle and I already know two of the sides, I like to go ahead and find the third missing side. In this case, the third missing side was side C. So since I'm looking for side C, I have to pick this equation because I already know angle C. And this third equation is the only one where I can plug in the value for angle C. So I go ahead and do that, pick the third equation for the law of cosines, and I start substituting. So 25 for A, 14 for B, and 60 degrees for angle C. Simplifying. And then finally, since we want to find C, we take the square root of both sides, and we get that C is equal to 21.7. For our second step, I want to go ahead and solve for angle A. Now, me personally, once I've got all three sides, I like to just start knocking out the largest angles in order. We already have angle C, so between angles A and B, I know that angle A has to be the largest angle because it's across from the largest side remaining. So here's the equation that I end up using. And I'm using this equation because since I'm looking for angle A, I pick the equation that has angle A in the equation. Once again, let's start plugging in some pieces. Plug in 25 for A, 14 for B, and 21.7 for C, which is what we just found. Simplify. And go ahead and solve for A. And we get that the measure of angle A is 86 degrees. Now the third step, if you're using the law of cosines, is pretty much always going to be the easiest step, because if you're looking for the last remaining angle, in this case angle B, well, we already know angle A and angle C, so we subtract those from 180 degrees, and that's going to get us the third missing angle, angle B, which is 34 degrees. And we have now solved the entire triangle. We have all three sides, 14, 25, and 21.7, and we have all three angles, 60 degrees, 86 degrees, and 34 degrees. In our second example, notice that we have a side-side-side triangle. And we know that with the side-side-side triangle, in order to not run into an ambiguous case, we want to solve the largest angle first, and the largest angle will always be across from the largest side. We can see that the largest side is 23.6, and that's across from angle B. So, first things first is I'm going to go ahead and solve for angle B. Notice that I'm using the law of cosines equation that has angle B in it. Let's plug in the pieces, 23.6 for B, 20.6 for A, 6.9 for C. Simplify as much as possible until we get to the point where we're solving for angle B. And we get that angle B is about 107.4 degrees. So for me personally, I like to go in order from the largest angle to the smallest angle. So since we found angle B, which was the largest angle, the second largest angle is going to be angle A, because the second largest side is 20.6. So that's what I ended up solving for next. So I use the law of cosines equation that has angle A in it. Again, plugging in the pieces and starting to simplify. We get that the measure of angle A is about 56.4 degrees. And now our third step, always pretty much the easiest step for the law of cosines. We have two of our missing angles. We know the third missing angle is going to be 180 degrees minus those two angles, which in this case will give us 16.2 degrees. So in these last two examples, problem 2 and problem 1, notice that in the work that I'm showing, I'm being very detailed in all the steps that I'm taking. In the last two examples, problem 3 and problem 4, I'm going to actually show you some more efficient ways so you don't have to show all the work step by step. I'm going to show you some more efficient ways to plug into a calculator and kind of shorten some of the work that you have to show. Okay? But let's look at problem 3 here. So notice problem 3 does not have a picture. In these scenarios, I think the smartest thing to do is always draw your own picture. So I went ahead and made my own triangle, ABC. I just put ABC in any order that I wanted to because once you put in the pieces that you're given, these three right here, the triangle will fall into place itself, okay? Notice we have a side angle side triangle. So usually, again, when I'm given a side angle side triangle, I like to find that third missing side first. And that missing side is going to be side A because it's across from angle A. So I set up the equation that has angle A in it. Now plugging in, this is what I'm going to get here. A squared equals, 17 is B, 18 is C, angle A is 89 degrees. Now one thing I can do though to kind of make the work a little less on myself is I know I'm going to plug it into a calculator and I want to get rid of this power of 2. So I'm just going to go ahead and take the square root of both sides. So instead of simplifying a lot of these pieces, like instead of simplifying and adding and multiplying here, I'm just going to go ahead and throw it all under a square root because the calculator is going to take care of that work for me. And this is going to give me A is equal to 24.5. What I think would be a good idea is for you to kind of pause the video at this point, plug this into whatever calculator you're using, make sure it's set to degrees, and make sure that you get the answer that I got, which is 24.5 for side A. If you're getting the correct answer, 24.5, then you're plugging this into the calculator correctly. All right, the second step. Now that I've got all three sides, again, I like to start knocking out the largest angles first. Of the two sides that we know, and of the two remaining angles, I know angle C is going to be the next largest angle because it's across from the next largest side, which is 18. So I'm going to go ahead and set up the equation using the law of sines equation that has angle C in it because I'm looking for angle C. Let's go ahead and plug in the pieces. And notice I'm going to be, again, a little bit more efficient with my space and with my work. I know that I'm looking for angle C. And in a typical problem, what I would do is I would simplify 18 squared. I would simplify 24.5 squared and 17 squared. Then I would add them together. Then we would end up taking whatever we get from this piece, and we would subtract it over to the left side. And then finally, whatever we would get from this piece right here, we would divide on both sides. And then lastly, to get rid of the cosine, we would take the inverse cosine. So thinking about all the different things that I would end up doing, I wouldn't combine them all into one step. Here's the 18 squared. Here's this 24.5 squared plus 17 squared that I ended up subtracting from the 18 squared. Here's the negative 2 times 24.5 times 17 that I would end up dividing by. And here's the inverse cosine that I would end up taking. So instead of showing every single step, which would take, 6-7 steps probably, I can throw all this into one step as long as I know the correct order. And in calculating that, I get the measure of angle C as about 47.3 degrees. Again, one thing that I would recommend is that you pause the video at this point, go ahead and plug this into a calculator and make sure that you're getting the same angle that I'm getting here. Now, if you're the kind of student that likes to go through and show every single step of work meticulously, that's perfectly fine. It's just going to take you a little longer to make the calculations. But if you'd rather do, your problems kind of like problem 1 here, where we showed every single little detail, every single step by step, that's perfectly fine. You'll arrive at the answer no problem. But if you want to take a little less time and combine some of these steps in one step, As long as you know the order that you're going in, then it works perfectly fine. Okay. And then our third piece here in this particular problem, well, the last thing that we're looking for is angle B. We have angle C. We already had angle A. So that's going to be a pretty easy one to find. Measure of angle B, 180 degrees minus the two angles we know. And we get that the measure of angle B is 43.7. And now we have solved the entire triangle. Okay. All right, one more problem I'm going to work through. And here we have another Tom Brady problem. This is an awesome problem. So here we go again. The year is now 2056. Brady has won a ring with every team in the NFL. But being Brady, he just can't stop winning games. So he's back here in the Super Bowl. Here's the GOAT, Tom Brady, throwing to two different wide receivers, wide receiver A and wide receiver B. The distance from Brady to wide receiver A is 25 yards. The distance from Brady to wide receiver B is 21 yards. And the distance from wide receiver A to wide receiver B is 26 yards. What we want to do is look at the triangle that's created between Brady and his two wide receivers, and we want to calculate each of the individual angles. Now, just to make things a little easier on myself, we're going to go ahead and assume that this is A, this is B, and I'm going to call Tom Brady C, just to make the law of cosines a little easier to understand. So we have a side-side-side triangle, and we know that with side-side-side triangles, we want to solve for the largest angle first. Well, the largest side is 26, and that's across from angle C. So we're solving for angle C first. All right, so we use the appropriate law of cosines equation right here. Again, notice we're solving for angle C, so I pick the law of cosines equation that has angle C in it. And we start plugging in some pieces. So we know side C is 26, side A is 21, and side B is 25. And once again, I'm going to be a little more efficient with my space. I know the order of things, so I go ahead and do everything in one step. The inverse cosine of 26 squared minus this 21 squared plus 25 squared divided by this chunk right here. And that's going to give me that the measure of angle C is 68.2 degrees. Again, if you want to show that step by step, you're more than welcome to. All right, so we found the measure of angle C was 68.2 degrees. That was our largest angle because it was across from the largest side. Again, I like to go from largest side to smallest side, or largest angle to smallest angle. And the next largest angle is going to be angle B, because that's across from the next largest side, which is 25 yards. So that's going to be my step 2. Since I'm looking for angle B, I pick the law of cosines equation that has angle B in it. And once again, let's plug in the pieces. 25 for B, 21 for A, and 26 for C. And again, I'm going to do all my work in one step. You're more than welcome to take your time with it. And I end up getting that the measure of angle B is about 63.2 degrees. And then finally, the last angle, which will be angle A, we can find pretty easily because we just found the other two angles. So angle A is 180 degrees minus the measures of angle B and angle C. And that gives us that the measure of angle A is 48.6 degrees.